Okay, so we're going to start talking about the periodic table. We already know a little bit about it, but we're going to do some more detailed analysis of it. The periodic table is pretty interesting, very, very useful tool. So we know about searching for the elements. Now we're going to search or figure out how we organize the periodic table. And I think you know a little bit about this already, but there are some interesting things. So, in the year 1700, there were only about 13 elements that were identified, and most of these had been known for thousands of years, like silver, lead, gold. And so chemists started to use scientific methods. They needed the elements were one of the first things they started to search for, and the discovery of those increased rapidly. In fact, one decade they discovered 5 new elements. So they used properties of the elements to sort them into groups. And in 1829, no, you don't need to know that date, chemist Dobryner published a classification system that was for the known elements at the time, and he grouped them into triads or groups of 3. And these 3 elements would have similar properties. And for one triad, chlorine, bromine, and iodine, they did look different. However, they had similar properties. He noted a pattern in his triad that one element always fell kind of midway between the first and the last in terms of something like average atomic mass. And so that he felt verified his organization of the periodic table. So why is it important for scientists to find a logical way to organize the elements? Well, it would make sure that the scientists were finding all the elements they were looking for, and they would be able to use them in other experiments. So in Mendeleev's time, he was writing a textbook, actually, and he needed a way of organizing the elements. And he came up with the modern periodic table. So he wrote the properties on a card, and that way he could move the cards around and try and arrange them in such a way that made sense. And in fact, you're going to do a lab like this, so it'll be kind of interesting. This organization he chose was a periodic table. The elements in the periodic table are arranged into groups based on their repeating properties. So that's one thing you're going to do. He also arranged the elements in order of increasing atomic mass. We now know that that's not the way they are organized, but at his time, that was a logical idea. So here's a picture of his actual arrangement of the periodic table, all typed out. And he arranged the elements with similar properties in the same row. We now use the same column for similar properties. He noticed that there were a few question marks. There are 2 question marks in between zinc and arsenic. And he left these places blank because he knew that bromine belonged with chlorine and iodine, so there must be something in between them that hadn't yet been discovered. So he was able to predict that elements would be discovered to fill in those spaces. And he also predicted what their properties would be based on the other elements in that row. The elements between zinc and arsenic were gallium and germanium, and they were discovered in 1875 and 1876. Nope, you don't need to know those dates either. And these were a close match between the predicted properties and the actual properties for those elements. And this match helped convince scientists that Mendeleev's periodic table was a powerful tool. So, why was Mendeleev's periodic table an improvement over Dobryner triad classification system and other earlier systems? He could use his table to predict compound or elements that were not yet discovered. And so that was very, very important. You might put a star by that. So how's today's periodic table organized? Because we no longer use atomic mass. So in the periodic table is based on atomic mass, and iodine should have come before trillium. Trillium is heavier than iodine. However, if we put it there, the properties would not line up. And so iodine does belong with bromine and chlorine, but we can't use atomic mass for that. So what Mendeleev thought was that the atomic mass of iodine and trillium were incorrect. However, they were correct, and there were other problems with certain elements, and it wasn't the atomic masses that were the problem. It was how we were trying to organize the periodic table. So, he developed his table before scientists knew about the structure of the atom. At this point, we haven't even discovered the electron, proton, and we certainly didn't know about the neutron. So he didn't know that atoms each had a unique number of protons, and we know that protons, the number of protons is the atomic number for that element. So here's the periodic table all laid out without any things being kind of pushed to the side to make it smaller. And you can see it's really wide. And that's why we take the F block and we drop it below, is just to make it fit a little bit better. So in the modern periodic table, elements are arranged in order of increasing atomic number. The elements that are arranged in that order, starting with hydrogen, which has an atomic number of 1. And we know who helped us figure out that it should be arranged by this number, correct? Because we watched that other video. There are 7 rows or periods in the periodic table, and each period corresponds to a principal quantum energy level. There are more elements in higher numbered periods because there are more orbitals and higher energy levels because there's more sublevels. And so the first row only has S, the second has S and P, etc. The properties of the elements within a period change as you move across from left to right. The pattern of properties within a period repeats as you move from one period to the next. And this is why we rearranged it for the elements in the same family to be in a column rather than in a row. This pattern gives rise to the periodic law. When elements are arranged in order of increasing atomic number, there is a periodic repetition of their physical and chemical properties. When elements are arranged in order of increasing atomic number, there's a periodic repetition of their physical and chemical properties. I just said that. Why do you think I repeated it? Yes, it is important. Elements with similar chemical and physical properties end up in the same column in our modern periodic table. So elements with similar properties are found in the rows or periods of the columns, or are they found in the groups or columns of the modern periodic table? Hopefully, after all the times I've repeated it, you can tell me that it is in the columns that we found are families or groups which have repeating chemical properties. I am going to stop here, and we will have a second video on this section as well. Okay, I'll see you in class. Bye.